Hello friends, welcome to Risingpearl.com. You know that we are talking about our series 2 where we are learning more about triangles. This is webisode number 6, and friends, today we are going to learn about this very important theorem on triangles. So the theorem goes like this. In any triangle, if a line is drawn parallel to one side that intersects the other two sides at two distinct points, then the other two sides are divided in the same ratio. So friends, like we always do, first we are going to find out what exactly is this theorem telling us, and then we will subsequently find out how can we actually prove that this is always the case. So let's find out what do we really mean by the theorem itself. So what we have done is we have drawn a triangle ABC, any triangle ABC, and let's now try to understand what the theorem is telling us. In any triangle, so we have a triangle ABC, if a line is drawn parallel to one side that intersects the other two sides at two distinct points. So let's first try to draw a line and find out. So what we have here is we have drawn a line D1, E1. So we have drawn a line D1, E1 such that the line D1, E1 is parallel to side BC. So in a triangle, if a line, in this case our line is D1, E1, is drawn parallel to one side of the triangle, the one side we chose is side BC. So we have drawn a line D1, E1 such that it is parallel to one side of the triangle, which is BC, that intersects the other two sides at two distinct points. Obviously, because we have drawn a line parallel to the third side BC, so this line actually intersects AB at D1 and AC at E1 respectively. Then the other two sides are divided in the same ratio. So this is the side BC to which D1, E1 is parallel to. So the other two sides are AB and AC. So what it is telling us is that this point D1 and this point E1, it divides the side AB and AC in the same ratio. It means that A D1 divided by D1B or BD1. So the ratio of this two measure, that is if you measure AD1 and if you measure D1B, so this ratio will be same as AE1 divided by CE1. So this is what the theorem is telling us. Now also, if I were to draw another line, say in this case D2, E2, again just making sure that the line D2, E2, this line is parallel to B1, C1. So instead of drawing the line like this, if I would have drawn D2, E2 as a line, then the theorem is telling us that the D2 and E2 would divide the line AB and AC in the same ratio. In that case, that is in the second case, I would have got A D2 divided by B D2. This ratio will be equal to A E2 divided by C E2. So similarly friends, as you can see, if I were to draw another line, third line D3, E3, again the same thing would be true. So in this case, as you can imagine, it will be A D3 divided by B D3 equal to A E3 divided by CE3. The reason, friends, I am actually drawing instead of drawing one line, I'm drawing 3 lines, is that just to highlight to you that the only requirement for each of these lines is that all these lines need to do, they need to be parallel to one side. So in this case, each of these lines are parallel to the side BC, and then they divide the other two sides AB and AC in the same ratio. So it really does not matter where we draw the line, as long as the line is parallel, they will divide the other two sides in the same ratio. So just to highlight that, I have just shown you with 3 different lines and the 3 different ratios. So now that we understand the theorem, what is it telling us, let's find out how can we actually go about proving that. So we start out with a simple triangle, right? Next, what we do is we draw a line. Yeah, let's get rid of all the D1 E1s and D2 E2s and D3 E3s. So in this case, what I have done, I have just simply drawn any line. In this case, it's line DE. So DE is such a line that DE is actually parallel to BC. So here, I have drawn the line DE in such a way that DE is parallel to line BC. Right? And friends, I could have taken any side. It doesn't have to be BC. If I had taken the side AC, then I could have drawn any line going this way, as long as any line going this way, which is parallel to side AC. Similarly, if I had picked the side AB, then I could have drawn any line like this over here or over here, as long as those lines are parallel to side AB, then they will divide the other two sides in the same ratio. So now let's keep going. So I'm going to do a simple construction. Actually, there will be 2 simple constructions that I would like to do. So first, from point E, I will drop a perpendicular on the side AB. So let us say that the perpendicular from E intersects AB at point P. That is, EP is perpendicular to AB. This is a construction. Similarly, I would like to draw a perpendicular from point D on AC. And let us say that that perpendicular intersects the line AC at point Q. After which, I would simply join the point C and D and the point B and E. It may look like there are lots of lines going across back and forth, but all we have done is simply, first we drew a line DE, right? And the only criteria for that is DE should be parallel to BC, right? Then from the point E, we drop a perpendicular on AB, and similarly from point D, we drop a perpendicular on AC, right? Why are we doing that? You will see that in just a moment. Now we are going to first focus our attention on triangle ADE. So let us just quickly, recap what we have, how we started off, right? So we started off with triangle ABC. Then we have been given line DE. This line DE is parallel to BC. This is given. And we need to prove that AD divided by BD is equal to AE divided by CE. This is what we need to prove. We are looking to prove this, right? And what we did, we made 2 construction. EP is perpendicular to the side AB, and similarly DQ is perpendicular to the side AC. This is what we have done so far. So at this point, we will actually focus on now triangle ADE. And why am I looking to focus on triangle ADE? You will see that in a moment. My goal is to figure out how can I actually get to the ratios, right? So recall that the area of a triangle, area of any triangle, right, is equal to half base times height, right? So if I look at triangle ADE, I can say that area of triangle ADE is equal to half base is AD. See, I'm trying to get to these sides. So half AD is the base and EP is the height, right? So half times AD times EP, which is the altitude. So half, just putting a dot here, which is multiplication, EP, right? So I can express the area of the triangle ADE in this fashion. Next, I'm going to look at this triangle, which is highlighted in blue. So here what I have is I have the area of triangle BDE. BDE. Now this is equal to half times, again I am trying to actually get to this measure BD. So the area of triangle BDE is nothing but half times base BD times height from point E. Again EP is the perpendicular, EP. So friends, what I have is now at this point, if I take a ratio of these two, so what do we get? We have area of triangle ADE, right, divided by area of triangle BDE. And now if you look at this, what you would have here is the half and half will get cancelled out. EP will get cancelled out. I am left with AD by BD. AD by BD. So as you can see friends, at least we have got the left hand side here, AD by BD. So what is this ratio AD by BD? It is nothing but the ratio of areas of triangle ADE and triangle BDE. That is what is AD by BD. So let us for the time being call this is our first equation. Now let's move on. Here in the subsequently now what we are going to do, we are going to now take a look at these two triangles. These two triangles, which is basically nothing but a triangle ADE and CDE. So here we are going to do the same thing. We are going to first write area of triangle ADE, and this time we are trying to focus on the right side. So what we will do is we are going to write this as, instead of expressing the area of the triangle with the side AD, we want to express the area of the same triangle with the side AE. So it will be half times base is AE, half times base is AE, times, if the base is AE, then the perpendicular distance or the altitude is DQ. Next, we are going to focus on the area of the triangle highlighted in red, which is triangle CDE. So this triangle, the area of this triangle will be half times. We are looking to focus on the side CE. So if this is the base CE, CE, and what is the altitude from this base? It will be the same length DQ. DQ. So if you look at if you take the ratio of these two, just the way we did it earlier, area of triangle ADE divided by area of triangle CDE. So what you have here is, if you take these ratios, this and this will cancel out and DQ, DQ will cancel out. So you are left with AE divided by CE, which is your right side. So what you see is that on the right side, AE divided by CE is nothing but the ratio of this triangle highlighted in yellow divided by the triangle highlighted in red, which is CDE. So let us call this as our equation number 2. Now, finally, if you focus on this triangle, triangle BDE highlighted in blue, and if you focus on the triangle CDE, which is highlighted in red. Now, friends, if you recall in our earlier season last class, we learned a theorem that if you take a look at any triangles with the same base, right? So triangles with same base, let's write it here, and between two parallel lines, if you have that, and which is what we have. So if you look at the triangle BDE highlighted in the blue and CDE highlighted in red, these two triangles have the same base DE and they are between the same two parallel lines DE and BC. If this is the case, then we know that the areas of these two triangles are equal. This is a theorem that we have learned. We have seen examples of this. We have learned about this theorem. We have done the proof of this theorem in our earlier class. So if this is the case, then the area of these two triangles must be equal. So area of BDE, it must be equal to area of triangle CDE. So friends, if you recall now, if this is true, so from our first equation, we have the area of ADE by BDE is nothing but this ratio, right? In other words, this ratio AD divided by BD, we saw that this ratio is nothing but it is equal to the area of triangle ADE. I'm just going to write it this way, ADE, just omitting the triangle symbol here, divided by area of triangle BDE. So from first equation we get this, and now we know that BDE is equal to CDE, right? So then I can write this as area of triangle ADE, right? Simply I am replacing BDE by CDE because these two areas are equal. CDE, right? Because these two areas are equal because of this theorem that we just talked about. Now equation 2 basically is saying that from area of ADE divided by CD is nothing but AE equal to CE. So friends, hence we have proved that AD by BD is indeed equal to AE by CE. So I know that we have kind of gone through a lot here, so I think let's just basically go back and find out, if you were to write this in an exam, how are you going to approach it in a step-by-step fashion. But friends, I wanted to highlight to you as to what is the thought process of how you will step-by-step look to prove a theorem like this. And like I have mentioned in the beginning, this is one of those very, very important theorems, fundamentally very important for you to realize and understand that, because you will see lots of different kinds of questions most likely coming in your tests on this particular topic. Now let's just go back, remove all of that, and let's find out how I'm going to write this in a step-by-step if I have to prove this theorem in the exam. So we always start out by talking about what we have given, right? We have a triangle ABC in which line DE, in which a line is parallel to the side BC. It intersects AB and AC at DNE respectively, as shown in the figure. Then what do? We need to prove. So first we write what is given, correct? And then we find out. So here, this is what is given. This part is given. And then we write what we have to prove. We have to prove the ratio AD by BD is equal to AE by CE. Then we do our construction. EP perpendicular to AB and DQ perpendicular to AC. We join BE and CD. Then we take the two triangles. This actually should be all the way here, and this should be all the way here. So then we look at these two triangles highlighted in yellow and blue. So we know that area of a triangle is half base times height. This is just the formula for area of a triangle, right? So area of triangle ADE is half AD times EP. For triangle ADE, half AD times EP. Area of triangle BDE is half BD times EP. We know that. And then if you were to divide these two areas, that is, if I were to do this, right? So I'm going to get this divided by this, and like we discussed, this will cancel out. EP cancels out. So I'm left with AD by BD. So this ratio gives us the areas. Ratio of areas will give us AD by BD. Call it equation 1. Now we take a look at these two triangles, and again we will do the same thing. So what we see is this ratio, that is area of triangle highlighted in yellow, ADE, divided by area of triangle CD highlighted in red. This ratio is nothing but this, AE by CE. Now this is what we were discussing at length. If you take a look at the triangle highlighted in blue, that is the triangle BDE, and if you take a look at the triangle which is highlighted in red, CDE, and this is the theorem that I was talking about, both triangles BDE and CDE have the same base. They have the same base and are in between same parallel lines DE and BC. So automatically from the theorem it follows two triangles will have the same area, and this is coming from the theorem, right? So if this is the case, then we will have basically, so from the first equation we have this, from the second equation we have this, and we just saw that the denominator, both these triangles, both the areas are the same. So we can say therefore that these two ratios are indeed same, and hence we have proved the theorem. So friends, I know that this has been a fairly long presentation, but I wanted to take the time to really explain step by step what this theorem actually states, and what do we mean by this theorem, and how we can actually prove that this theorem is indeed accurate. And the reason we spent so much time on this theorem is that because you will see lots and lots of questions regarding this theorem in the topic of similar triangles. So friends, in the next video, we will learn about the converse or the opposite of this theorem.